Tonight, we drift far beyond Earth, past the Moon, past Mars, until we reach the orbit of Jupiter, the giant king of planets shrouded in cloud and thunder. But we're not here for the storms. We've come for something smaller, colder, quieter, Europa. At first glance, it's just another moon, a pale, cracked sphere spinning silently in the freezing vacuum, forever caught in Jupiter's gravity. But Europa holds a secret, a possibility so vast it has haunted our imagination for decades. Beneath that fractured ice lies an ocean, vast, dark, and ancient. An ocean that may be alive. This is not a story of explosions or discovery in the usual sense. It is a guided sleep story about patience, silence, and listening to the distant whispers of the cosmos. As we float closer, you'll see no flickering lights or cities, just ice. A frozen shell wrapped around something so hidden, even light has never seen it. NASA calls Europa one of the most promising places to search for life beyond Earth. The upcoming Europa Clipper mission will orbit, scan, and study the moon's every detail. But tonight, we don't need high-speed data or deep space antennas. Just your imagination. Just the gentle rhythm of words as we sink into the idea of oceans in the dark. Imagine a world where sunlight never reaches the surface, a place where heat comes from within, pulled and pressed by the enormous gravity of Jupiter itself. That's how Europa stays warm enough for water. Not lakes, not puddles, but an entire global ocean locked beneath a crust of ice, perhaps 20 kilometers thick. This is your bedtime story for grown-ups. This is the kind of ASMR storytelling that doesn't just help you fall asleep, but takes you somewhere. Europa is more than a frozen moon. It is a question wrapped in silence and waiting. What stirs beneath its icy skin? Could there be life, not as we know it, but strange, alien, and beautiful in its own way? Let the thought carry you now. Let the cold become comfort. Let the mystery become peace. The surface of Europa stretches before us, cracked, lined, grooved. No mountains, no wind, just patterns, like scars frozen in time. But somewhere deep below, the ocean moves. And where there's water, there might be wonder. Close your eyes. You are drifting in orbit. The vastness of space behind you. Europa ahead. And now, let's begin. In the cold, outer reaches of our solar system, beyond the asteroid belt and the burnt orange dust of Mars, there orbits a world so small it might seem forgettable. Europa is no larger than Earth's moon, and yet, in the quiet halls of science and among the dreams of astronomers, it looms enormous. For Europa may be the single most compelling place in the solar system to search for life. Jupiter, its massive host, holds dozens of moons. Some are chaotic rubble piles, others are volcanic furnaces. But Europa's is different, delicate, smooth, and silvery. Seen from orbit, it looks like a world made of frost and fractures, as though the whole moon has been frozen mid-motion. Unlike cratered neighbors, pockmarked by ancient collisions, Europa's face is oddly smooth. Cracked, yes, but unscarred. It hints at a surface that reshapes itself, that heals, that moves. We begin with the basics. Europa is the fourth largest moon of Jupiter and the sixth closest of its many companions. Discovered in 1610 by Galileo Galilei, one of four major moons that now bear his name, it has been in our telescopes for centuries. But only recently have we truly begun to see it. Europa is a moon of water. Its icy crust may be up to 20 kilometers thick, but beneath it, evidence suggests, lies an ocean more than 100 kilometers deep, far deeper than anything on Earth. Despite its small size, just 3,100 kilometers in diameter, Europa likely contains more water than all of Earth's oceans combined. A staggering thought, more liquid water in the vacuum of space, locked beneath an alien sky. But how can this be? How can a frozen moon orbiting so far from the sun hold a warm ocean underneath? The answer begins with Jupiter and with motion. Europa is trapped in a gravitational dance with its siblings Io and Ganymede. Together, they form a resonance that keeps Europa's orbit slightly elliptical. As it swings closer and farther from Jupiter, the planet's immense gravity pulls and releases the moon in a regular rhythm. This flexing causes tidal heating, stretching and squeezing Europa's interior like a ball of clay warmed in the hand. The result? Internal friction, internal heat, and the possibility of liquid water, sustained not by sunlight, but by motion and gravity. This is not just theory. Observations from NASA's Galileo spacecraft, which orbited Jupiter from 1995 to 2003, brought compelling clues. Magnetometer readings hinted at a conductive layer beneath the ice, likely a salty ocean. Images revealed strange surface features, long curving ridges, chaotic terrain, blocks of ice that seemed to have drifted and rotated, as if floating on something beneath. All these point to one incredible idea. Europa's crust may be a shell, not a solid. And where there is liquid water, even buried deep, the possibility of life emerges. Europa is often compared to Earth's own icy environments, the deep oceans near hydrothermal vents, or subglacial lakes sealed beneath Antarctica for millennia. In these places on Earth, life thrives in complete darkness, sustained not by photosynthesis, but by chemical energy from below. Could something similar stir beneath Europa's crust? We do not know. Not yet. But the mere possibility has changed the way we think about life in the universe. Once we looked for alien life in Earth-like conditions, warmth, light, and surface water. Europa taught us that life might hide in the shadows, in deep oceans beneath ice, warmed not by stars but by planetary tides. It taught us that silence is not absence, that a world with no atmosphere, no surface lakes, no forests, may still be alive beneath. In this way, Europa became more than just another moon. It became a symbol of a new kind of search, not for radio signals or green men, but for biology in the most unlikely places. A place for robots, landers, and someday explorers. And so we wait. NASA's Europa Clipper, scheduled to launch soon, will orbit Jupiter and fly by Europa dozens of times. It will scan the ice, search for plumes, and probe the magnetic field. It will look for chemical signatures and perhaps find evidence that the ocean beneath is not silent. But this is not that story. Not yet. Tonight, we imagine Europa not through the lens of instruments, but through the quiet lens of wonder. A cracked moon gliding silently around a giant with an ocean in its heart. It is a moon of possibility, a question mark wrapped in frost. Let's stay in orbit a little longer. Let the silence of space wrap around you. Picture Europa turning slowly, its fractures catching the pale sunlight. Beneath those fractures, deep beneath the shell, the ocean swells and shifts, untouched for billions of years. It is waiting, and so are we. Europa's surface is silent, a stillness so complete it might seem like nothing lies beneath. No winds to stir dust, no rivers to carve valleys, no voices to echo in empty skies. But under that pale, fractured crust, the silence is deceptive. Beneath Europa's ice lies motion, liquid, pressure, and perhaps life. To imagine this hidden ocean, begin with a sound, not one you can hear with ears, but a kind of gravitational rhythm. As Europa orbits Jupiter, its massive parent tugs at it with relentless force, not just once, but constantly, in pulses, in waves, like a heartbeat, driven not by biology, but by orbital mechanics. This rhythm bends Europa's interior ever so slightly, over and over. Unlike Earth's moon, whose orbit is nearly circular, Europa's is slightly stretched, elliptical. That means its distance to Jupiter changes as it orbits, and with each change, the giant planet's gravity stretches and releases the moon's body. This flexing causes friction inside, heat generated not by sunlight, but by motion itself. The result is extraordinary. Even though Europa's surface lies in deep cold, a frigid 100 Kelvin, far below water's freezing point, the interior is warm enough to melt ice, warm enough to keep a vast ocean liquid for billions of years. Let that idea settle for a moment. An ocean, possibly global, sealed inside a moon, not warmed by sunshine, not fed by rain, but alive with movement, fed by tides in total darkness. NASA scientists believe this ocean could be 100 kilometers deep. That's 10 times deeper than the Mariana Trench, Earth's deepest point. And unlike Earth's oceans, this one has no surface. It presses directly against ice above and rock below, a world between worlds, caught in the balance of pressure and gravity. The ice that covers Europa is not uniform. Observations from Galileo and other missions show that it's broken, cracked, and chaotic in places. These patterns suggest movement, slabs of ice rotating, colliding, submerging. It looks strangely like sea ice on Earth. In some regions, long ridges stretch for hundreds of kilometers, double-peaked like frozen waves. In others, terrain appears churned and shattered, as if something below has pushed upwards. One theory suggests the ice crust may not be rigid throughout. Instead, it could be broken into plates, mobile, like slow-moving tectonics. Some areas might be thinner, more flexible. Beneath these thinner spots, ocean water might even touch the base of the crust or seep upward through fractures. And then there are the plumes. In recent years, the Hubble Space Telescope and other instruments have detected hints of water vapor erupting from Europa's surface, geysers bursting into space as if the moon is venting pressure from deep within. These plumes aren't confirmed with absolute certainty, but if real, they could be direct evidence of exchange between the ocean and the surface, a cosmic leak in the icy shell. For planetary scientists, this is electrifying. If water from the ocean is escaping into space, future missions like Europa Clipper or ESA's JUICE spacecraft may not need to land at all. They could simply fly through the vapor and sample it. The ocean, hidden for eons, might be revealed not through drilling, but by listening to its breath. But what is this ocean made of? What stirs inside it? We don't yet know the chemistry, but there are clues. Europa's surface is covered in frozen water, but also strange reddish-brown markings. These dark streaks may contain salts, possibly magnesium sulfate or sodium chloride, carried up from the ocean below. This suggests the water is salty, conductive, and chemically active. On Earth, life needs more than water. It needs energy and nutrients. Europa's ocean may have both. The rocky seafloor at the bottom of this alien ocean might resemble Earth's, rugged, volcanic, alive with heat. On our planet, deep sea vents spew minerals and heat into the abyss, creating entire ecosystems without sunlight. Creatures live there: tube worms, crabs, bacteria, thriving on chemical reactions instead of photosynthesis. Could Europa's seafloor be similar? If so, the ocean might support life not just in concept, but in practice. Simple microbes, perhaps, or something stranger, life adapted to pressure, darkness, and alien chemistry. Not little green men, but something far more realistic. Extremophils in a foreign sea. It's a haunting thought that beneath this moon's frozen face, an entire world may be alive and completely unaware of us. No eyes to look up, no minds to wonder, just slow biological rhythm pulsing in the dark. In this bedtime story for grown-ups, Europa becomes a mirror for Earth, a reminder that life doesn't need continents, clouds, or sunshine, just warmth, water, and time. Some scientists call Europa's ocean a potential biosphere, not because we know it contains life, but because it checks so many boxes: liquid water, a stable environment, chemical energy sources. It's not a fantasy. It's a possibility, a quiet one, but profound. Even if the ocean is lifeless, it is still beautiful. The idea of a sea untouched for billions of years, sealed under ice, never stirred by wind or storm, it's poetic, like a secret kept by the universe, not out of malice, but patience, waiting for us to listen, and we are listening. Europa Clipper will orbit Jupiter and perform dozens of flybys of Europa. It will map the ice, sniff for plumes, analyze surface chemistry. It will send back data, clues, whispers. Perhaps it will confirm the ocean. Perhaps it will glimpse the shadows within. For now, we imagine. We drift. The ice groans below us, slowly flexing with every orbit. The ocean shifts, unseen. The surface lies still, but beneath it, Europa breathes. We'll go deeper soon. We'll explore what signs of life might exist, what chemistry might feed it, what lessons Europa has for us. But for now, let this idea carry you. A world beneath a world, glowing softly in darkness. Close your eyes. You're still floating above the moon, orbiting quietly. Somewhere below, an ocean moves, and maybe, just maybe, something listens back. There is a quiet question that hums beneath every conversation about Europa. Could something be alive down there? It is not shouted, not declared with certainty, but it lingers in the pause after every scientific paper, in the silence between each mission update. A whisper beneath that ice. Europa may be, in all its alien stillness, one of the most plausible places in the solar system to harbor life. Not intelligent, not visible, but alive in the most basic, ancient sense of the word. Life as chemistry, life as survival, life as persistence. To understand how this might be possible, we have to look not outward, but inward to the places on Earth where life hides from the sun. There are places beneath Antarctica where lakes lie buried under kilometers of glacial ice. In the darkness of Lake Vostok, sealed off for millions of years, microbial life may exist, surviving in complete isolation, thriving on minerals and slow chemical reactions. In Earth's deep oceans, where sunlight never reaches, entire ecosystems flourish near hydrothermal vents, underwater geysers where the planet bleeds heat and chemicals into the sea. Here, life takes strange forms. Worms with no mouths, bacteria that digest sulfur, creatures that have never seen the sky. And so we ask, if life can exist there, in the dark, under pressure, without light, why not on Europa? The ocean beneath Europa's ice may be rich in the ingredients life needs. Water, certainly, but also salt, minerals, and energy, not from the sun, but from within. Tidal flexing may not only keep the ocean liquid, but drive geological activity on the ocean floor. If Europa has hydrothermal vents, like those on Earth, They could serve as oases in the abyss, pumping heat and nutrients into the water, sparking chemical reactions, feeding microscopic life. We do not yet know if these vents exist. We do not know what chemicals drift through Europa's ocean. But every piece of data gives us new reasons to wonder. Spectral readings from the moon's surface suggest the presence of sulfates and chlorides, salts that may have come from the ocean below. The reddish-brown lines that scar the ice might be evidence of oxidized minerals or organic compounds altered by radiation. In 2018, NASA announced evidence of water vapor plumes erupting from the surface, possibly delivering ocean material into space where it might be sampled without drilling. If those plumes are real, they're a revelation. It means that Europa's ocean isn't isolated. It breathes in small exhalations, offering pieces of itself to the stars, and we are listening. The upcoming Europa Clipper mission will carry instruments designed to detect organic molecules, the building blocks of life. It will sniff the thin atmosphere. It will scan the surface for signs of chemistry that doesn't quite belong. It will search for patterns, isotopic ratios, molecular structures, spectral fingerprints that might hint at biology. But what exactly would count as a sign of life? That's where science becomes art. We do not yet have a universal definition of life. On Earth, life is carbon-based, water-dependent, and driven by energy flow. But those traits are shaped by our own planet's history. In the depths of Europa's ocean, life might follow different rules, still chemical, still real, but unfamiliar. Perhaps it exists as simple single-celled organisms, extremophiles clinging to rock, feeding on sulfur or iron, never evolving eyes or limbs, never dreaming. Or perhaps it takes stranger forms, long tendrils drifting through the dark, jellyfish-like creatures pulsing slowly in warm currents, colonies of microbes building strange mineral structures over eons. We do not know what to expect, and in that not knowing, there is a kind of beauty. Because the search for life on Europa isn't just about finding microbes, it's about asking deeper questions. How common is life in the universe? Does it emerge whenever conditions are right? Or was Earth a singular accident? Is life fragile or inevitable? These are not just scientific inquiries, they're philosophical, even spiritual. To find life on Europa would be to shatter the illusion of cosmic loneliness. It would mean that biology is not a fluke, but a tendency, something the universe does when it can. But even if we find no life, the search itself changes us. It forces us to redefine habitability. It teaches us that warmth can come from motion, not sunlight, that life might bloom in the cold, that oceans can hide beneath silence. Europa becomes, in this way, a mirror. It reflects our hopes, our fears, our endless curiosity. It invites us to consider that life and meaning might dwell where we least expect them. In your guided sleep story tonight, let this idea carry you, that the silence of Europa is not empty, but patient, that its ocean might be a cradle, slow and dark and rich, that in a world with no sky, life might still rise softly in the depths. It is humbling to imagine, and comforting too, because if life can grow beneath Europa's ice, it means life is not fragile. It is resilient. It means the universe is not dead, but sleeping and full of quiet dreams. As you drift deeper into rest, picture the ocean not as absence, but as presence, a slow-moving tide beneath the stars, a darkness full of chemistry and potential, and perhaps beneath it all something stirs. The surface of Europa is a map of fractures. From a distance, the moon gleams smooth and clean, pale white, streaked like marble, drifting silently around Jupiter. But up close, it tells a different story. The ice is broken, scratched, scarred, not by impacts like so many other moons, but from within. It is not the story of violence from above, not craters or collisions, but of pressure from below. Europa's surface is not static. It flexes, bends, and breaks as the ocean beneath it shifts and swells. Each orbit around Jupiter brings tides that squeeze and pull, and the ice, though cold and hard, yields, not quickly, not explosively, but slowly, as if sighing under cosmic tension. The result is a world of lines, long, curving fractures called linea, run across the surface in great arcs. Some stretch for thousands of kilometers. Others form complex networks, as though the moon has been etched by a vast and invisible hand. These cracks are not random. They carry meaning if you know how to listen. To planetary scientists, these lines are records of motion. They trace how the icy shell responds to gravitational stress, how it creaks under pressure, how it may even rotate slightly over time, a phenomenon called non-synchronous rotation, where the crust shifts independently of the moon's interior. Imagine a sphere of water wrapped in ice. Now imagine that shell being stretched and squeezed in slow cycles, like the flexing of muscle. That's Europa. The ice breaks, but it also moves. Some regions appear to be covered in blocks of ice, jigsaw-like chunks that seem to have drifted apart and rotated as though floating on something fluid. This chaotic terrain, seen in images from the Galileo spacecraft, is one of the most compelling pieces of evidence for a subsurface ocean. The surface didn't just crack, it rearranged, and in some places, it may even open. There is growing evidence that Europa vents its internal ocean into space. In 2012, the Hubble Space Telescope captured ultraviolet signatures suggestive of water vapor above the moon's south pole. Later observations in 2016 and 2018 reinforced the idea. Transient plumes jetting hundreds of kilometers into space, perhaps from fractures in the ice. These plumes, if real, are the closest thing we have to a voice from Europa's ocean. They are small, fleeting geysers, like Old Faithful on Earth, but millions of kilometers from home. If a spacecraft like Europa Clipper flies through one, it could analyze the vapor directly, tasting the sea without ever touching the surface. But where do the plumes come from? The best guess is that Europa's ice contains pockets of liquid water near the surface, possibly fed from the deeper ocean. As pressure builds in these reservoirs, fractures provide a release valve, a way for water to escape into the void. This would make Europa not just a moon of hidden depth, but one of interaction, where ocean and surface connect through a network of subtle cracks. Even without plumes, the fractures themselves may serve as conduits. Heat from below, along with pressure from Jupiter's gravity, may keep some of these cracks warm enough for brines, salty water mixtures, to rise slowly through the shell. When they reach the cold surface, they freeze instantly, leaving behind deposits of minerals and salts that stain the ice in shades of rust and ochre. This could explain the strange reddish lines that cross Europa like ancient writing. To us, they are beautiful. To science, they are fingerprints, traces of chemistry and motion and time. And still, we wonder what lies beneath them. Could life, or signs of it, rise through these cracks? Could biology hitch a ride on rising brine, frozen into the surface, waiting to be discovered? We don't know. But the cracks are a bridge, not just structurally, but symbolically. They connect the surface to the deep. They make Europa a moon in conversation with itself. It's this dynamic nature that sets Europa apart from other icy worlds. Many moons are frozen solid, locked in place for billions of years. But Europa is restless. Its surface is young, geologically speaking, perhaps only 50 million years old. For comparison, Earth's continents are hundreds of millions of years old, and the moon's oldest craters stretch back over 3 billion. On Europa, the ice is recycled. New fractures overwrite old ones. Chaos terrains erase history. The moon is rebuilding itself again and again from the inside out. This means that anything that does reach the surface, from plumes or slow upward migration, is relatively fresh. If we want to read Europa's story, we need only look at the latest lines, and perhaps listen to what they're whispering, because cracks aren't just damage, they're openings, they're possibilities. On Earth, we fear them. They mean weakness, collapse. But on Europa, they are how the moon breathes, how it speaks. In this bedtime story for grown-ups, we reframe the fracture, not as flaw, but as invitation. Europa's surface is cold, silent, and radiant, but it is not dead. Every line you see, every curved ridge, every jumbled block is the result of motion, pressure, and the invisible push of an ocean that refuses to stay quiet. And still, No one has walked there. No one has touched that ice. All we have are images and guesses and dreams. But that is enough for now. Because through those cracks, we imagine. We imagine what it would be like to stand at the edge of a geyser and watch a plume rise into Jupiter's sky. We imagine peering into a deep chasm in the ice and hearing the faint groan of movement far below. We imagine drilling someday and finding something that pulses, not a signal, but a rhythm. The rhythm of a living ocean, ancient and slow. And whether or not that ocean holds life, it holds meaning. Because Europa reminds us that stillness can be deceiving, that silence can be full, that cracks are not the end of things, but the beginning of listening. So as you drift further into sleep, picture the surface of Europa, bright and broken, etched with messages we are only beginning to read. And beneath those lines, imagine the ocean again, moving, waiting, listening. The first time humanity saw Europa, it was only a dot. It was January 1610. Galileo Galilei, peering through his handmade telescope, noticed that Jupiter was accompanied by 4 tiny stars that seemed to move from night to night. They weren't stars of co-Earths, they were moons. The 4 largest in Jupiter's system, now known as the Galilean satellites, Io, Europa, Ganymede, and Callisto. In that moment, Europa became real to us, not just a mathematical prediction or a mythic idea, but an object in the sky, orbiting another world. It would take centuries before we saw it up close. For most of history, Europa remained a mystery. It was simply a moon, small, cold, and far away. Through telescopes, it offered little more than a glint of light, a smooth disk, too faint for detail. It wasn't until the 1970s that we truly began our voyage. In 1979, NASA's Voyager 1 and Voyager 2 spacecraft flew past Jupiter. For the first time, we saw images of Europa's surface, not just a blurry speck, but a world. The pictures stunned scientists. Instead of a cratered wasteland, Europa appeared smooth, bright, and fractured. It looked like no other moon, like nothing we expected. The surface was unlike Mars or Mercury. It resembled cracked glass or Arctic ice under pressure. Long, winding lines crossed the globe, and there were few craters, suggesting a young and active surface. Something was happening there, something alive with motion, if not with biology. These images planted the seed of a question: what lies beneath? But the Voyagers were only passing by. They couldn't stay. They offered glimpses, not answers. The next great leap came in 1995 when NASA's Galileo spacecraft entered orbit around Jupiter. Over the next 8 years, Galileo flew past Europa more than a dozen times. With every pass, it revealed more: higher resolution images, magnetic readings, spectral analysis of the surface. One of the most important discoveries came not from photographs, but from a magnetic anomaly. As Galileo passed through Europa's environment, its magnetometer recorded something strange: a distortion, a wobble in the magnetic field that suggested a conducting layer beneath the surface. Something salty, something liquid, an ocean. Not long after, close-up images of chaos terrain, jumbled blocks of ice that seemed to have drifted and rotated, reinforced the idea. The ice, it seemed, was floating on something. The possibility of a subsurface ocean became more than speculation. It became the leading hypothesis. Europa had moved from the edge of awareness to the center of planetary science. Yet even Galileo had limits. Its instruments were designed in the 1980s. Its onboard tape recorder failed. The data was valuable, but incomplete. It told us enough to dream, but not enough to understand. Still, we were watching. Later missions, like NASA's Juno orbiter, focused on Jupiter itself, but continued to gather useful context, mapping the planet's magnetic field, radiation environment, and gravity, all of which affect Europa. Meanwhile, telescopes on Earth and in orbit, including the Hubble Space Telescope, began detecting hints of activity, possible plumes of water vapor erupting from the surface, perhaps from subsurface reservoirs, or even the ocean itself. The idea that Europa might be leaking, whispering, into space electrified the community. And so, a new mission was born. NASA's Europa Clipper, set to launch soon, is the most ambitious effort yet to explore this icy world. It will not orbit Europa. Jupiter's radiation makes that dangerous, but it will perform nearly 50 close flybys, each one gathering data from different regions of the moon. Its instruments are designed specifically for Europa. Radar that can see through ice, spectrometers to analyze surface chemistry, a magnetometer to map the ocean, cameras to capture the fractures and ridges in fine detail, and a mass spectrometer that may fly through plumes, sampling their contents, sniffing for organics, salts, even biosignatures. Clipper will not answer every question. It will not land, it will not drill. But it will give us the clearest picture yet, not just of Europa's surface, but of its heart. The European Space Agency is also joining the story with its mission JUICE, the Jupiter Icy Moons Explorer. Though JUICE will primarily focus on Ganymede, it will also conduct flybys of Europa, adding a second perspective. Together, these missions represent not just technological achievement, but human patience. We've waited decades. We've watched from afar, and now, slowly, methodically, we are returning. But we have not yet touched the ice. That dream belongs to the future, to robotic landers, drillers, perhaps submarines that might one day swim beneath the crust. These missions are not yet built. Some exist only as sketches, but they are coming, and the path to them runs through Clipper and Juice, because before we dive, we must listen. Before we touch, we must see. Every spacecraft we send to Europa is a question in flight. What are you? What lies beneath? Are you silent or simply not yet heard? And there is something poetic in the slowness of it all. In an age of rapid communication, Europa teaches us to wait, to orbit, to return again and again to the same path, gathering clarity one flyby at a time. It is science as meditation, as ritual, a kind of cosmic listening. In your ASMR storytelling sleep journey tonight, picture yourself aboard Europa Clipper, silent and weightless, gliding over the moon's bright surface. The cracks pass beneath like ancient script. Instruments whir softly. No voices, just sensors, just questions. And as you look down, you feel it. Not just the cold, not just the wonder, but the presence of something vast, something ancient, something moving below. This is the beauty of exploration, not just in answers, but in the act itself, in the reaching. Galileo's telescope, Voyager's first glimpse, Galileo's slow orbit, Hubble's quiet stare, Clipper's long journey to begin. Each step is part of the same sentence, a sentence we are still writing. And Europa, in all its silence, is listening. There is something deeply unsettling and quietly beautiful about an ocean no one has ever seen. Beneath Europa's fractured shell lies a sea untouched by light. No sun has ever kissed its waves. No eye has ever glimpsed its currents, and yet it has likely existed for over 4 billion years, silently moving beneath a frozen sky. In this chapter of our guided sleep story, we won't talk about sensors or missions, not yet. Instead, we turn inward toward imagination, reflection, and the strange peace that comes from thinking about a hidden sea. Europa invites us to adopt a different mindset, so one that resists urgency and one that embraces the slow. On Earth, oceans are vibrant with motion. Waves crash, tides roll, storms brew. Our oceans are alive in every sense, noisy, visible, chaotic. But Europa's ocean is quiet. If it moves in darkness. If it stirs in secret. There is no sky, no wind, no surface, just the deep. To even imagine it, we have to slow down, to let go of earthly expectations. On Europa, things happen not in days or years, but in millennia. Plates of ice may shift by centimeters per century. Heat may rise over eons. If there is life down there, it may be in no hurry. It may never have known speed. This is the ocean mindset. It is the understanding that slowness does not mean stillness, that silence does not mean emptiness, that waiting is not wasted time. Europa teaches us to think like a planet, or rather like a moon, steady, cold, enduring. It reminds us that not all things that matter make noise, that not every miracle announces itself. On Earth, we define life by motion, metabolism, growth. But these are forms, not the essence. What if life is more than activity? What if it is a presence, a persistence, even in the absence of action? Europa's ocean forces us to stretch our definition, not to abandon science, but to let it evolve, to ask, could life exist not in competition, but in calm? Could consciousness emerge not in a rush toward survival, but in slow adaptation? Imagine a creature born into darkness. No light, no sky, no concept of a surface. It knows only water, only chemistry, only motion and heat. It grows slowly, if at all. It never moves far. It doesn't need to. The environment is constant. The rhythms are ancient. Life here is not about exploration, but balance. Would we recognize such a being as alive? And more importantly, would it recognize us? Europa, in its quiet orbit, reflects something deep in the human psyche. Our own longing for peace, our own need for rhythm, the desire to be part of something ancient, something steady, something that does not demand performance. In that way, the ocean beneath the ice is not just an alien sea. It is a metaphor, a symbol, a place where we project our questions about existence. What does it mean to be alive? What does it mean to be alone? What does it mean to wait? These are not technical questions. They are emotional, existential, poetic. And Europa, though it may never speak, seems to echo them back, not with answers, but with space. In this bedtime story for grown-ups, let's linger with that idea that some things are worth knowing even if they take 100 years to uncover. That presence matters, even without proof. Europa's ocean mindset is not passive. It is patient. The difference matters. Patience implies intent. Waiting implies hope. When we talk about sending probes, landers, submarines, we are expressing faith, not in technology, but in the idea that silence can be meaningful, that a dark ocean can be worth exploring. That mystery is not a void, but an invitation. And if we find life, even microbial, even brief, it will change us, because it means that the universe tends toward life. That given time, water, and energy, something stirs. And if we do not find life, then Europa still changes us, because it teaches us that not all searches end in discovery, but that the search itself is sacred, that curiosity is enough, that the act of listening, of really listening, matters. The ocean beneath the ice becomes a mirror. We see ourselves in its potential, our own fears, our own dreams, reflected back through layers of frozen silence. We think of loneliness as emptiness. But what if loneliness is simply space between songs? What if Europa's oceans is humming and we have not yet learned to hear? As you drift deeper into rest, imagine that ocean again. Picture its darkness not as absence, but as shelter. Picture its pressure not as burden, but as embrace. Imagine it as a great, slow heartbeat, ancient, rhythmic, alive in its own way. This is the ocean mindset. Not loud, not quick, not easy, but vast, and perhaps one day connected. There are places in the universe we dream about long before we understand them. Europe is one of those places. For decades now, it has floated through our science and our sleep, a distant moon wrapped in ice, whispering of oceans and silence and secrets. We have watched it from afar. We have mapped its scars, felt its magnetic breath, and imagined what lies beneath. But Europa has always been a question. Now that question is becoming a destination. In the coming decades, if the world remains steady and our curiosity strong, we will return to Europa, not only with flybys, but with touch. We will land, we will drill, we will reach through the ice and try, at last, to listen properly. This is the next frontier. Imagine it. A lander descends through Jupiter's harsh radiation, touching down gently on a field of fractured ice. Around it, the sky is black, except for Jupiter, looming huge above, a swirling giant painted in storms. The surface of Europa stretches in all directions, cold and bright, quiet as a grave. There is no wind, no atmosphere to carry sound, only the soft mechanical murmur of human instruments, arms that extend, drills that lower, cameras that scan. We will begin, as we always do, by studying, measuring the chemistry of surface salts, sampling particles from plumes, listening for vibrations, for any movement from within, taking photographs not just to analyze, but to send home, postcards from a frozen dream. Later, perhaps decades later, will come the most ambitious mission of all, a cryobot, a robotic probe designed to melt its way through kilometers of ice. Slowly, patiently, it will descend into darkness, its heat cutting a narrow shaft down through the crust. Behind it, the ice will freeze again, sealing its passage. It will be, for a time, alone in the most complete sense. And then, perhaps, it will reach the ocean. No sunlight, no color, only pressure and water and silence. A second robot, a Hydrobot, may emerge from the cryobot's core, unfolding like a deep-sea fish, activating its lights, its sensors, its cameras. It will swim forward, slowly, cautiously, and it will look. What will it see? Perhaps nothing but water, minerals, salt, a slow current, the movement of a world without awareness. Or perhaps, just perhaps, it will find something that glows, something that pulses, something that moves not with the machine's motors, but with its own rhythm, a thread of biology, a response. It may not be intelligent, it may not even be multicellular, but if something moves, if something metabolizes, then we will know we are not alone, not in the cosmic, dramatic sense, but in the biological one. And that will change everything, not because we'll have found aliens in the way we once imagined them. No starships, no languages, no civilizations, but because we'll have found life born of another cradle, another sea, a second Genesis. It will mean that the universe knows how to make life more than once. And if it happened here, under Europa's crust, then it could happen anywhere. Titan, Enceladus, exoplanets we've never seen, even rogue worlds, drifting through the dark without a star. Life, we'll realize, is not rare. It's waiting. But there are other possibilities too. We may dig, we may descend, and we may find nothing. A silent sea, no cells, no reactions, no life. Would that be failure? Number. Because in reaching, we grow. Europa is not just a goal, it's a mirror. It reflects our desire to know, to understand, to listen, even when the answer might be silence. We go not because we're sure of what we'll find, but because we're not. And perhaps that's the most important reason. We are, after all, not just explorers of the stars. We are explorers of meaning. In the coming century, we may ask ourselves questions no one has ever asked before. If we find life on Europa, what are our responsibilities? Do we protect it? Do we study it? Do we isolate it the way we quarantine fragile ecosystems on Earth? If we find nothing, do we try to seed life, to introduce microbes, algae, synthetic biology, and see if it takes root? If we build a colony, do we treat Europa as a resource, a place for mining or shelter or survival? Or do we treat it as sacred? There are no easy answers. But we will have to ask, because the dream of a Europa colony is not fiction anymore. Already, thinkers at NASA, Blue Origin, SpaceX, and academic institutions around the world are sketching the outlines. Domed habitats buried in the ice, shielded from radiation, subsurface labs powered by nuclear or solar energy, human researchers living in rotation, diving into science by day and returning to warmth by night, children born under ice, generations who will never see a blue sky, humanity writing a new chapter not on another planet, but on a moon. Europa, they say, could be a stepping stone, a test bed, a sanctuary, but it will also be a teacher, because Europa forces us to confront a paradox. To explore it deeply, we must disturb it. To know it, we must touch it. To reach the ocean, we must break the ice. So we will have to ask, again and again, how much is too much? In this bedtime story for grown-ups, let's not rush to answers. Let's stay in the question a little longer, because perhaps the real gift of Europa is not the data we'll gather or the samples we'll return, but the way it reshapes our perspective. It teaches us to listen better, to wait longer, to see the sacred in silence, to look at a moon bright and cracked and quiet and say, this matters. Not because of what we take from it, but because of what it gives to our imagination, to our ethics, to our sense of belonging in the cosmos. Europa is not the end of exploration. It's the beginning of a new kind, a kind rooted in awe, a kind that treats mystery not as a problem, but as a presence. As you drift now into the final part of this journey, let Europa linger in your thoughts. Imagine the ice above you, thick, glowing, groaning gently with the pull of Jupiter's tides. Imagine the ocean below, vast, dark, quiet, alive in its own way. And somewhere in between, imagine us, drifting, asking, learning. The next frontier is not just out there, it is within, in our ability to wonder, to love what we do not yet understand, to reach even when no one answers back. Europa waits, and we are learning how to listen.